But because 6 is not, and both have to be met, the large sample condition is not met. Yes?
Like, why
10? That's a good question.
It's like an arbitrary number, like, it should be bigger than 10 on both sides. Right? Just people come up with that.
It has to do with the complicated math in the central limit theorem, okay? And it's just that when you have...
So it's not just like a really convenient number, there's backing.
There is some backing to it, and it's 10, n times p turns out to be what we call the expected value, okay? And so you have to expect at least 10 successes and at least 10 failures in order for the central limit, in order for it to look like a normal model. Otherwise, you're going to end up with something that looks skewed. Okay, so, and depending on the textbook you read, other textbooks might say 7 is an okay number, and others will say 5. Okay, but 10 is a safe number to use. Okay, yes.
So if we're given like a value rather than a percentage, should we use the alternative method, and if we're given a percentage, use the other method? Or
yes, if you're given a percentage, plug it into n times p. If you're given a value, just do the number of yeses and the number of no's, or successes and failures. Okay. So in this case, 6 is not bigger than 10, but 54 is. Okay, but both have to be met. So the large sample condition is not met. Is that okay? Should we try another one of these, or are we feeling okay? We'll do another one, all right. Okay. Is the random condition met? Yes. Alright, because in the problem it says we randomly selected people. What about a big population? No. Okay, well, alright, well, what is our sample size?
30.
Our sample size is 160. Alright. And what is our sample? People with glasses. So what is the population?
I don't know.
The population would be all people ever, or all people who wear glasses. okay? Because we're selecting 160 people with glasses, so the population represents everyone we could possibly want to study. And if we're selecting people with glasses, then that would be everybody who wears glasses. Is that okay? So the population,
So we should assume that it's just like of everyone.
yeah, so if it doesn't specify, then the population would be everyone who could possibly be considered. Okay? So the population is everyone with glasses that can be considered. Okay? So is our population bigger than 10 times our sample? Yeah, okay, so 10 times 160 would be 1,600 people. Do we think that there's more than 1,600 people who wear glasses? Yeah, okay, so our big population condition is met. What about our large sample condition? Is that met? Okay, so how many successes do we have? 30. Successes is 30. How many failures? 160 minus 30. So we have 100. So if 30 people visit the optometrist every year, then 130 people do not. So our large sample condition is also met, because both of those numbers is bigger than 10. So in this case, all of our conditions are met. All conditions are met. Meaning we can use the central limit theorem. Yes?
I'm a little confused on the big population part.
Okay.
Like, how can we assume that everyone, how can we assume a number for everyone that wears glasses if we don't know the number?
Yeah, we don't know the number, but just from our, I guess, our common sense. Okay. So if the population is everyone, at least in America, everyone in America that wears glasses, is there more than 1,600 people? Yeah. Okay. Is this feeling all right? More, or are we done with this?
I think
We're done? We're good? Okay, why don't we take a 10-minute break then?